This is a May-June 2023, 42 variant. Question 1A carries 2 marks. We have to define Newton's law of gravitation. Newton's law of gravitation states that the gravitational force between two point masses is directly proportional to the product of the two masses and is inversely proportional to the square of their separation. Therefore, the formula for gravitational force is equals to G m big M times small m over r squared. And then for part B, a satellite is in circular orbit around a planet. The radius of the orbit is r and the period of the orbit is t. The planet is a uniform sphere. Use Newton's law of gravitation to show that r and t are related by the formula. This is a formula where m is the mass of the planet and g is a gravitational constant. This question carries 2 marks. In order to get the 2 marks, 1 mark here, 1 mark here, we need to first state that the gravitational force between the two objects provides the centripetal force for the object to move in the circular motion. Therefore, you can equate gravitational force G m over r squared equals to centripetal force mr omega squared. If I use this formula here, then must use omega equals to 2 pi over t because the final expression contains the period. Or you can use the gravitational force equals to mv squared over r, which is your centripetal force. If I use the second equation, this equation here, then must use v equals to 2 pi r over t. So that when you substitute either your omega into this formula, mr omega squared, or v equals to substitute into mv squared over r, I will get finally 4 pi squared r cubed equals to gmt squared, which is proven. That's how you get the 2 marks. And then the Earth may be considered to be a uniform sphere of mass 5.98 times 10 to the power 24 kilogram and radius 6.37 times 10 to the power 6 meter. A geostationary satellite is in orbit around the Earth. Use the expression in B to determine the height of the satellite above the Earth's surface. You can see that in this question, you need to know, number 1, the conditions for geostationary satellite. And then secondly, the question asks to find the height of the satellite above the Earth's surface. So you can use the formula 4 pi r cubed equals to gmt squared. So you substitute this into the question, you get r equals to 4.22 times 10 to the power 7 meter. This answer is the distance between the satellite and the center of Earth. But since we want to find the height of the satellite above the Earth's surface, we must minus the radius of the Earth. So this will give you 3.6 times 10 to the power 7 meter. Another satellite is in circular orbit around the Earth with the same orbital radius and period as the satellite in part C. But calculate the angular speed of the satellite in this orbit. Give a unit for your answer. This question carries 2 marks. The formula for angular speed of the satellite is omega equals to 2 pi over t. So this will carry 1 mark. And then the other mark is the answer plus the units. This will therefore equals to 2 pi divided by 24 hours. This will give you 7.3 times 10 to the power 5, 7.3 times 10 minus 5 radian per second. So this is angular speed. Then for part 2 of your D, despite having the same orbital period, the orbit of this satellite is not geostationary. Suggest 2 ways in which the orbit of this satellite could be different from the orbit of the satellite in C. Again, we must know the condition for the satellite to be geostationary. For the satellite to be geostationary, besides the satellite moving above the equator, it must move from west to east. So the orbit is from east to west, maybe, and then the orbit is not equatorial. Maybe the orbit is polar. Satellite is moving over the north and south pole rather than above the equator. And then this is a summary of the facts that you must know to solve this question. Number 1, you must state Newton's law of gravitation. Number 2, understand that the gravitational force provides the centripetal force for circular motion. Number 3, equate gravitational force to centripetal force to obtain 4 pi squared r cubed equals to gmt squared. And then number 4, explain geostationary satellite and state the conditions for the satellite to be geostationary.